So we'll start off with number 1. So number 1 and 2 of the worksheet, we are looking at some shapes, particularly a polygon and a rectangle. Looking at number 1 here, we see a polygon. A polygon is this shape with many sides, and it says find the perimeter. So when it says find the perimeter, that's the key word, and the perimeter means to add up all the sides of the shape. So what you're going to have to do in this problem is simply just add up these sides. It says be sure to include the correct unit in your answer. So we got to be careful of that when we are answering our question. So here, if you add up all the sides, you're going to get 13 plus 14 plus 13 plus 19. You could do this by hand, or you could plug it into your calculator. So if I do this by hand, 3 plus 4 is 7, plus 3 is 10, plus 9 is 19. Carry the 1, 1, 2, 3, 4, 5. So the answer is 59, and we are finding the perimeter, so we just answer it as in 59 feet. The second question asks you to find the area. So this is the area of a rectangle. So when you find the area of a rectangle, one of the formulas that you need to know, area is equal to length times width of the rectangle. So you want to multiply the two numbers together. So you have length times width, 12 times 7. So 12 times 7 will give you can plug into your calculator, or if you know by heart, hopefully, the answer is 84. And you want to answer it with units. So if there's feet, you want to put feet squared is your answer, because feet times feet is feet squared. Next up, we're going to be talking about absolute value. So this is number 3 on your worksheet. So number 3 on your worksheet asks you to find the absolute value of 5 and the absolute value of negative 10. These bars that you see on the sign on the sides means absolute value. So here I've written out the question. So these bars again means absolute value, and the definition of absolute value is that it is the distance from the origin. So when you want to talk about distance of something, the answer is always going to be positive. So for an example, if I say, how far do you live from Long Beach? If someone says they live 10 miles north, they would just say 10 miles north, or 10 miles. If they live 10 miles south, we don't say negative 10, we just say 10 miles, right? So whenever we answer a question with an absolute value in it, the answer for that portion will always be positive. So here, when we see the number 5, the answer is going to be 5 because it's the positive version of 5. The negative 10, the absolute value of negative 10 will be positive 10. Also, another way of looking at it in terms of visually, the origin is the number 0 in the middle. Numbers to the right are positive. So if you have the number 5 here, so when they ask you what is the absolute value of 5, what is the distance from 0 to 5, from the origin to 5, then the answer is 5. And then here's 10, so 10 is way down here, negative 10. So here's the negative direction. If they ask you what's the distance between 0 and negative 10, in other words, what's the absolute value of negative 10, then your answer is positive 10, because that's the distance. Next up, we're going to be talking about converting a percentage to a decimal for problem number 4. It says write 30% as a decimal. So when we want to convert a percentage to a decimal, keep in mind that whenever you see the percent sign, which is this is percent, the word percent literally means percent, which literally means divide. So per means divide, and cent means 100. So if you think of the word century, there's 100 years. Centipede, there's 100 feet. So here, percent means divide by 100. So whenever you see the word 30%, think divide by 100. So if you want to change this to a decimal, you could write it as 30 divided by 100. And I'm sorry, that's actually changing it to a fraction. But 30 divided by 100, if you put this into your calculator, this becomes 30 divided by 100 is 0.3. 0.3 there. So I know a lot of you guys remember it as move the decimal twice to the left. I want you to understand why you're moving it twice to the left. The reason is because you are dividing by 100. When you divide by 100, you get this answer. So again, one way of thinking about it is move the decimal twice to the left. But better yet, understand that percent means divide by 100. Next up, we're going to look at number 5 and 6 on your worksheet. Notice there's addition sign in the middle, so we're going to be adding. And notice that these numbers, some of them are positive numbers and some of them are negative numbers. Positive or negative numbers are called integers. When we think of adding or subtracting integers, I want you to think about the number line. So if I have a number line here, so for those of you that are visual, zeros in the middle, to the right side are the positive numbers, to the left side are negative numbers. So to the right side are positive numbers, 1, 2, 3, 4, etc. And then to the left are negative numbers, -1, -2, -3. So when we look at the addition sign, what I'm going to do first is I take the first number 3. It's a positive 3. You don't have to have a plus there. It could just be blank. So positive 3. So that means I'm going to move 3 spaces to the right because it's positive. So I'm going to move from the origin. I'm going to move 3 spaces to the right. So I'm right here. And then -4. So -4 means that I move to the left 4 spaces. Here I move to the right 3 spaces. And here, because it's negative, I'm moving to the left. So from 3, I'm going to move to the left 1, 2, 3, 4. 4 spaces. So therefore, I end up at -1. So my answer here is -1. Same story with the bottom one here. So I'm going to start off with moving 3 spaces to the left. So left 3 spaces. So I'm going to go 1, 2, 3. So I'm at -3, right? So I'm here. And then I'm going to move another 5 spaces to the left. So when I move 5 spaces to the left, 1, 2, 3, 4, 5, I end up being at -8. So when I put these together, I get -8. Problem number 6, we have these two problems. And as you can see, drawing number lines is not going to work because it's going to take forever to go -36 spaces and then +31 spaces. So we want to see if there's a shortcut instead of drawing number lines. So the shortcut is something that you have to notice from what we did in number 5. When you are adding one number that's positive and one number that's negative, so they have opposite signs, you're going to have to subtract the numbers together. So when you subtract 4 and 3, you get 1. And the one with the bigger number, so the number 4 is bigger, has a negative sign, that one wins the sign, you get negative. Because for here, we walked to the right 3 spaces, and then we walked to the left 4 spaces. So we walked more to the left than to the right. So therefore, we want to end our answer with a negative answer. So we subtract our answers. So here in this case, -36 plus 31, I'm going to walk to the left 36, and I'm going to walk to the right 31. Well, how many, did I take more steps to the left, or did I take more steps to the right? I took more steps to the left, right? Because 36 is bigger than 31. So I know my answer is going to be a negative. And as we can see here, we're going to subtract the two numbers together. So we're going to subtract 36 from 31. We end up getting 5. So the answer is -5. For the second part here, notice if you have two numbers that are of the same sign, you're walking the same direction. So here I went to the left 3 spaces, and then I went to the left 5 spaces. So I'm walking the same direction the whole time. So therefore my answer is going to be the addition of these two numbers, and that's why it was 8. And since we walked to the left, we're making it negative. So here we're walking to the left 28 times, and we're walking to the left 30 times. So when we're taking 28 steps and 30 steps, we're going to add these two together. When we add these two steps together, we get 58. And since we walk to the left, we know we're on the left side, so it's going to be -58. So in summary, so the shortcut is this. Instead of drawing number lines, we're going to say when adding numbers with the same sign, such as what we did in this problem, we add the numbers together because we're walking in the same direction, and then we keep the sign that it's in. So here, since we walk to the left, then we're going to say it's negative, right? So what happens when we're adding numbers with the opposite sign? So let me write this down. When adding numbers with the opposite sign, notice that what we are doing is that we are walking or taking steps in different directions. So here, negative 36 plus 31, we walked 36 steps to the left and then 31 steps to the right. So we're walking in different directions. Since we're walking different directions, we need to subtract the two numbers together. So when we're adding numbers with opposite sign, we subtract the two numbers. We subtract the numbers together. And then in terms of whether it's going to be a positive or negative answer, it depends on whether you walked more to the left or did you walk more to the right. In this problem, we walked more to the left because we took 36 steps to the left and only 31 to the right. So which direction did we walk further? We walked to the left further. And the left was a negative, so therefore it was a negative answer. So here we say the bigger, quote unquote, the bigger number wins the sign. So that's how you know if your answer is going to be positive or negative. All right, next up, we're going to talk about subtracting integers. So here is subtracting integers. We look at questions number 7 and 8. Notice in number 5 and 6, the main symbol that we're using is addition. Even though there's minus signs here. Here in 5 and 6, we're adding negative numbers. So make sure we realize that that's adding. Now in 7 and 8, notice that the main operation in the middle is the negative sign, the minus sign, which means subtraction. So when we subtract, let's see what we need to do. So when we subtract integers, first thing we need to notice is that there is a minus sign in the middle, right? And we see minus signs here and here as well. But remember, this here means subtraction. So it's a little bit confusing. This is subtract, and here this is a -4 and a -1. So these are negative numbers. And then whereas the symbol in the middle means subtraction. So -1 minus a -4. So the first thing that you want to do in any subtraction problems is that you want to change it to addition. So subtraction and addition are kind of like related to each other, like brothers and sisters in a way. So when we think of subtraction, the first thing we want to do, so I'm going to write it here. So step 1 is to change subtraction to addition. And how you change a subtraction to addition is that you take the opposite of the second number. So what do I mean by this? Take the opposite of the second number. So here, I'm going to change this to plus. So I'm going to say this is now addition. So the first number was -1. I leave -1 the same. Plus this -4 here now becomes a +4. So this -4 becomes a +4 because we take its opposite. And by doing that, then this can become an addition symbol. So here, -1 plus 4, we go back to our rules for adding numbers. So since you have opposite signs, you're going to subtract the numbers. So here, back to the rule of adding integers. We're taking one step to the left. So I'm going to do this again. Start at 0. It's like you're taking one step to the left, so you're at -1, and then you take 4 steps to the right. 1, 2, 3, 4. So now you're at the number 3. So the answer here is 3. And again, the shortcut is that when you notice that they're opposite signs, that means you're moving in one direction, then the other direction. So you want to subtract the numbers together. And then the one where you took the greater steps is the one that wins the sign. So 4 is bigger than -1. You moved more towards the right than the left, so that's why it's a positive. So let's try the next problem here. 6 minus a -4. I'm going to change this to a positive, or to addition. So 6 plus, and this -4 now becomes a +4. And when you add that, what's 6 plus 4? The answer is 10. Or if you think of this visual, you move 6 steps to the right and 4 steps to the right. So since you're moving the same direction, you add the numbers together. And since you're moving to the right, you make it positive. Okay, the next problem here, -35 minus 36. So again, I'm going to make this into an addition sign. And then this number 36 will now become a -36. So again, this is subtraction, becomes addition. This positive 36 now becomes a -36. And here I have a -35 in the front. So -35 plus a -36. So we're adding two numbers which are moving to the left. right? They're both moving to the left. So if they're both moving to the left, you're going to add these numbers together since they're going the same direction. When I add these numbers together, I get 71. And since we're moving to the left, we need to say it's a negative sign. Last but not least, 7 minus a negative 2. So I'm going to make the subtraction sign into an addition sign. So 7 plus, and this negative 2 now becomes a positive 2. What's 7 plus 2? It equals to 9. Or in other words, move 7 to the right, 2 to the right. You've taken a total of 9 steps to the right. Now we take a look at number 9. Here we have an adding and subtraction all mixed in together. So how do we do a problem like that? So we have adding and subtraction mixed in together. What we're going to do is we are going to work on this problem left to right. So when you're dealing with adding or subtraction in a problem, you're going to move from left to right. So work from left to right. So I'm going to look at this and I'm going to just go left to right. 7 minus 3. Well, 7 minus 3 will give me 4. 4, now I'm going to rewrite this problem. So now I'm going to look at these two, 4 minus 10. 4 minus 10, if you could do it in your head, great. If you can't do it in your head yet, we could write it out. It'll be the same thing as 4 plus, because here's a minus sign. And I'm going to change this 10 to a negative 10, right? Because this positive becomes a negative. So 4 plus a negative 10, since I am taking 4 steps to the right and then 10 steps to the left, I'm going to be subtracting the numbers, so I get a 6. And then the more steps that I took to the right or the left will win the sign. And here I took more steps to the left since 10 is bigger than 4, so that's going to be a negative 6. So now I have negative 6 plus 9 minus 8. Now I'm going to do these two, negative 6 plus 9. So I'm adding now. I'm adding two opposite signs. So I'm moving 6 to the left, 9 to the right. So I'm going to subtract the numbers since I am moving in different directions. So 9 minus 6 will give me 3. And is it positive or negative? Well, it's going to be positive because I took more steps to the right since 9 is bigger than 6. So it'll be 3. 3 minus 8. And last but not least, I see a subtraction sign. I'm going to change this to addition, and this positive 8 will now become a negative 8. So what do? These are opposite signs. So I'm going to subtract the numbers together. So 8 minus 3 is 5. And is this a positive or negative number? It's going to be negative because 8 is bigger than 3. I took more steps to the left than I took to the right. In question 10, we have a problem that consists of multiplying and dividing integers. So when you're multiplying and dividing integers, first thing you can do is just multiply the numbers. So 3 times 6 will give me 18. 3 times 6 is equal to 18. Now it's a negative 3 times a negative 6. So some of the rules for multiplying and dividing integers is that if you have a negative times a negative, times a negative, it's going to equal to a positive. So negative times a negative will always give you a positive. A positive times a positive will also give you a positive. The only time you have a negative answer is if you have opposite signs. So if you have a negative times a positive, that will give you a negative, or vice versa, if you have a positive times a negative, that will give you negative. So these are the rules of multiplying or dividing integers. If they have the same sign, then you have positive answers. If they have opposite signs, then you have negative numbers. So whenever you're dealing with math, always remember the rules. That's what you want to memorize, the rules of math. So in this problem here, this is a negative times a negative, so my answer is going to be positive. In the second part, 24 divided by 4. So first I ignore the signs and I'd say 24 divided by 4 will give me 6. And this will be a negative answer because this is a positive divided by a negative. So they're opposite signs, so I get negative 6. In number 11 here, we see that we have division. 0 divided by 3 and 5 divided by 0. So whenever you see a fraction sign, it's another way of writing division. We see zeros in them. So how do we divide when there are zeros in it? So in this problem here, the first part is 0 divided by 3 and then 5 divided by 0. So the rules for dividing with zeros is the following. Whenever you have a number and you divide it by 0, the answer is always going to be undefined. You can never have a 0 in the denominator. We can never have a 0 in the denominator. So if you forget that rule, you could always check with your calculator, right? If I try putting like 8 divided by 0, we end up getting dividing by 0 errors. So you ever forget, you just plug in your calculator and you'll see that it's undefined. So here in this problem, 5 divided by 0. So another way of writing that is 5 divided by 0, or write it as a fraction, 5 divided by 0. We're going to write that the answer is undefined because there's a 0 in the denominator. So what happens if there's a 0 in the numerator? So 0 divided by any number. Well, 0 divided by any number, if you put that into your calculator, say 0 divided by 8, you're just going to get a 0. So 0 divided by any number is just going to give you 0. So 0 in the numerator is A-OK. 0 in numerator is OK. It's OK to have a 0 in the numerator, but you just cannot have a 0 in the denominator. So here, 0 divided by 3, another way of writing that is writing it as a fraction, and the answer is just 0. Now we look at number 12 and 13. 12 and 13, we see fractions. So now we are seeing fractions, and we're either adding or subtracting them, and they either have positive or negative components to it. So let's look at this. First of all, let's talk about the rules of adding or subtracting fractions. So the rules are this. So first thing is that we must have common denominators or like denominators in order to combine them, in order to add or subtract them, in order to add or subtract the fractions. So if you do not have the same denominator, you cannot combine them. So in other words, I'm just going to write this in general. If I have A over B plus C over B, so just using letters to represent random numbers, as long as the denominators are the same, then I keep the denominator the same, and then I could add or subtract the numerator. So here the numerator is A plus C, right? So here I can combine them as long as the denominators are the same. So what happens if you do not have the same denominators? If we do not have common denominators, we must create common denominators. We must create or find the lowest common denominator. And that's another word, that's another way of saying the LCD for short. So here, the LCD is a really important word. So we have to find the common denominator and create it, and then we could go back to this rule. So one of the things I love about math is that it's so powerful. If you see something that you don't like, guess what? You have the power to change it, but you have to change it within the rules of math. So here in number 12, I look at the denominators because I see this as an adding and subtraction. Again, this is only these rules are only pertaining to addition and subtraction, not for multiplication and dividing. So here I'm seeing that this is an addition sign. So I'm going to look at the denominator. Okay, 7 and 3, they are not the same, so I cannot combine them as is. So to create the lowest common denominator, what I ask myself is, what is the LCD? In other words, what is the lowest common multiple? So I'm going to ask myself, what is the lowest common multiple of the numbers in the denominator of 7 and 3? So what does 7 and 3 have in common as a multiple? So when I think of the number 7, I think of the multiples of 7 are 7, 14, 21, 28, yada, yada, on and on. When I think of the number 3, I think of the multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, etc. Right? So it goes on and on. So I want to find what is the lowest common number. So between 7 and 3, the lowest number that they have in common is the number 21. So 21 is the lowest common denominator. So hopefully after you do this many times, you won't have to write it all out, but if you need to, feel free to do so. But after a while, you'll be able, if you could do it in your head, it's a lot faster. And that's why doing homework problems and practice problems helps you to get faster at these things. So now I'm going to manipulate this fraction so that it has the lowest common denominator of 21. And you can ask the good question, say, well, how can you just change 7 to 21? How is that legal, right? You can't just change numbers. So one of the rules with math, with fractions, is whatever you do the bottom number, you must do the top number. So what did I have to multiply by to go from 7 to 21? I needed to multiply by a factor of 3. So I needed to multiply by 3 in order to get 21 in the denominator. Again, the rule with fractions is whatever you do the denominator, you must do to the numerator. So if I multiply by 3 on top, then I must multiply by 3 on, if I multiply by 3 in the bottom, I must multiply by 3 on top. So 3 times 1 is 3 on top. And don't forget that negative sign that's sitting out there. Next up, 3 to 21. What do I need to multiply by to get to 21? I need to multiply by 7. And whatever I do at bottom, I must do the top. Because math is all about being fair, right? You got to keep it fair. So here, 2 times 7 gives me 14. Now that I have the same denominator, now I can combine the fractions using this rule. So the denominator stays the same. So when I add these two together, I get 21 on the bottom. The top, I get negative 3 plus 14. Well, what's negative 3 plus 14 on top? Well, since they're opposite numbers, a negative and a positive, I'm going to subtract the numbers because we're walking to the left, then walking to the right. So you're going to subtract the numbers. So we're going to get 11, and it's going to be positive. 14 minus 3 is 11. It's going to be positive because we took more steps to the right. 14 is positive, so you make the 11 over 21. And I want to ask myself, is this simplified? So one of the rules, again, I'm going to write this down, is always simplify your answer. So simplify means to write it in lowest terms. So 11 over 21, do they have any numbers that they can divide by? And the answer is no, they can't divide by anything other than themselves. So the answer is 11 over 21. Now let's look at number 13. So here I see the addition sign. So right away, I know I need a lowest common denominator because the negative 5 and 3 are not the same. So I see this negative 5 here. Just letting you know this negative sign can either go on top or on bottom. So if it trips you out to see a negative in the denominator, put it on top, right? If it trips you out. So ignore this negative here and just put the negative on top. So it doesn't matter where the negative goes. So first of all, I'm going to look for the lowest common denominator of 5 and 3. Ignore the negative sign, pretend it was on top. So the lowest common denominator of 5 and 3, what is that? Well, I think of the multiples of 5, 5, 10, 15, 20, 25. The multiples of 3, 3, 6, 9, 12, 15, 18, etc. What did they both have in common that was lowest? They both have in common the number 15. So I'm going to do my magical math, and I'm going to create a fraction where they are both 15. And again, in order to change it, I need to follow the rules of math. To go from 5 to 15, I needed to multiply by 3. So whatever I do bottom, I must do the top. So the top, I get 18. Remember, though, there's a negative here. So I don't like putting on the bottom. I'm going to put the negative on top. That's totally fine. Here, to go from 3 to 15, I needed to multiply by 5. So whatever I do on top or in the bottom, I do on the top. So negative 2 times 5 gives me negative 10. Now that I have the same denominator, I can apply this rule where you combine the fractions when you have the same denominator. So my answer then will be, I have 15 in the denominator. On top, I have negative 8 plus a negative 10. So back to adding fractions. Since I am adding adding integers, since I'm adding two numbers that have the same sign, this means I'm walking to the left 18 steps and I'm walking to the left 10 steps. So you're going to add these two numbers together. So you're going to get 28. And since you are walking to the left, your answer is going to be negative 28 over 15. Is this my final answer? So here I ask myself, is 28 and 15, can I divide it by any number? And the answer is no. Like 5, I could divide by 5 and 3, but 28, I cannot divide by 5 or 3. So therefore, this would be the final answer. Next up, we have number 14 and 15. So number 14 is about multiplying fractions, and number 15 is about dividing fractions. So when we talk about multiplication, when you look at this, a lot of students look at this and they think that it's a subtraction problem because they see a minus sign, but that is not the case. So notice that there's a parentheses. So here's a note multiplication can be written in different ways. So multiplication can be written as A times B, so A and B representing any number. So there's a multiplication sign there. It could be written as a dot, A times B, like that. It could be written with parentheses next to it. So if you have two numbers or letters next to each other with parentheses, that means it's multiplication. I could have just parentheses around one item or this item, right? So whenever you have parentheses sitting next to the numbers, that means that it's multiplication. So here in this case, I have 4/3, and even though I see a subtraction sign, that is actually a negative number. So the negative 1/8 is attached, the minus sign is attached to 1/8, so it's a negative number. It does not mean subtraction, so be careful of that. So because there's a parentheses, that's how I know that this is a multiplication problem, because there's parentheses around it, and it's saying this multiplied by this, a positive number multiplied by a negative number. That being said, let's talk about multiplying fractions. So the rules. So rules of multiplying fractions is if you have A over B times C over D. So notice when we did adding and subtracting fractions, one of the rules is that you needed to have the same denominator in order to combine, but that is only for addition and subtraction of fractions. When you're dealing with multiplication and division of fractions, you do not need the lowest common denominator. All you do is you multiply across A times C, and you multiply the bottom, B times C. So you do not need a lowest common denominator. So life is a little bit easier multiplying than adding or subtracting. So here in this problem, I'm going to multiply the numerators together. 4 times 1 is 4. 3 times 8 is 24. And remember, the rule of multiplication is if you're multiplying a positive times a negative, then your answer is going to be negative. It doesn't matter whether you put the negative on the top, the bottom, or to the side. It's just as long as it's there. Am I done with this problem? No, because I always want to make sure that my answer is simplified, meaning there's no other number that can divide by it. So 4 and 24, do they have anything in common that they can divide by? And the answer is yes. They both, the top and the bottom, can be divided by 4. If you divide the top and the bottom by 4, you get 1 on top, and the bottom, you get 6. Am I missing anything? Yes, I am. I'm missing the negative. And again, the negative can go anywhere. When we're talking about dividing fractions, there's only one extra step. The step is this. If I had someone change up the letters, M over N divided by R over S, I write letters just to represent any arbitrary number. You want to change this to multiplication. So when you change to multiplication, so what you're going to do is you're going to change the second fraction. So M over N times R of S, what you do is you flip it over, or in other words, you multiply it by the reciprocal of the second fraction. So the reciprocal means that you flip it upside down. So you multiply by the reciprocal, so it's a fancy word, of the second fraction. So you flip it upside down. So that's the rule of dividing fractions, right? So here, when I see this problem, first thing I'm going to do is I'm going to change it to multiplication, and then I'm going to find the reciprocal of the second fraction. So this becomes 3 over 8. I flip it upside down. Where does the minus go? It doesn't matter. You can put it in front, top, or bottom. And the first fraction stays exactly the same. So I get this here. So one of the things I can do is I can multiply across. So I'm going to show you two ways of doing this problem. One way is I can multiply across, so 16 times 3. So if you plug that into your calculator, you get negative 48, because there's a positive times a negative. And the bottom, 21 times 8, I don't know how to do that in my head, so I just use a calculator. 21 times 8 is 168. So over 168. And then when I look at this, I say, well, holy smokers, that's a huge number. Can I simplify this? Yes, I can. What do I simplify by? So I'm going to have to divide it by a number that they have in common, yada, yada. And then this goes on and on to simplify. So when I see something like this, I'm like, okay, these are really big numbers. Is there another way of simplifying first? And the answer is yes. So if I want to simplify first, just to make my life a little bit easier, I look at the top, the numerator and the denominators, and I ask, are there any factors that they have in common that I can simplify before I multiply it out? So when I look at the top and bottom fractions, I look at the number 3 on top and the 21 on the bottom. and say, hey, the 3 and the 21, what do they have in common that they can divide by? They can be divided by 3. 3 divided by 3 is 1. 21 divided by 3 is 7. So whatever you do the bottom fraction, you do the top fraction, and that's a rule. So I divided the top by 3, the bottom by 3, so it's legit. I look at the number 8 and 16. Do they have anything in common? Yes, they have an 8 in common. 16 divided by 8 gives me 2. 8 divided by 8 gives me 1. So now I can multiply across with these numbers. 2 times a negative 1 will give me a negative 2. The bottom 7 times 1 will give me 7. So this will be my final simplified answer. So question number 16 is asking us to write a mixed number as an improper fraction. So this is a mixed number. A mixed number contains a whole number and a fraction. So that's called a mixed number. So a mixed number has a whole number and a fraction. So that's why it's called mixed, right? A mixed number. So sometimes you'll have to change a mixed number to an improper fraction. So where you just want it as a fraction without the whole number in it. So an improper fraction basically just means that you want to write this as one fraction without the whole number. And how you do that is you take the bottom number here and this whole number and you multiply them together. So 7 times 3 is 21. So I'm going to put 7 times 3 here. 7 times 3 is 21. Right? And then you're going to add that number to the numerator plus 5. So 7 times 3 is 21, add 5, you're going to get 21 plus 5 is 26. And then you're going to keep the denominator the same, 26 over 7. So notice that the top is heavier than the bottom, the numerator is bigger than the bottom. That's why it's called an improper fraction. So an improper fraction is when the numerator is bigger than the denominator. And vice versa, if you want to change this to a mixed number, what you do is you just divide it. What's 26 divided by 7? Well, 26 divided by 7, the one, 2, 3, 4, 5, 26. So 26 divided by 7, what is 26 divided by 7? Well, the biggest number that could be divided by is 3, right? Because 7 times 3 is 21. So 21, and then what's the remainder? Well, you have a remainder of 5 because you need to add 5 more to get 26. So 26 divided by 7 is 3 with a remainder of 5. So I put the 5 on top and then I put the denominator here. So you're back to the beginning. So in this problem, to write as an improper fraction, it is 26 over 7. In numbers 17 and 18, we see that we have what we call exponents. So if you look at this little 2 here and this little 3 here, these are called exponents. What are exponents and how do we evaluate them? So here in this problem, it's really important to ask ourselves, well, here's the exponent, what is the base? So whenever you have an exponent problem, you want to ask yourself, what is the base? So the base, so here I'm going to write it in terms of letters just to represent arbitrary numbers. If I have a to the m power, right, the bottom number is called the base, right, bottom base. So this is the base. And then the m on top is called the exponent. The little number on top is the exponent, the base is here. So what exponents are is exponents is a really shorthand way. Exponents is a shorthand way of doing repeated multiplication. So I mentioned before that math is like a language. So if you think of in the English word, like say cannot, right? Cannot, if you want to make it short, you could say can't, right? So there's, in the English language, we can shorten words up just to make it convenient. Same thing with mathematics. So you can shorten repeated multiplication by making it exponents. So for an example, if I had something that said 3 squared, So the base is 3 and 2 is the exponent. That is basically repeated multiplication of the base. So what I do is I take the number 3, that's the base, and I'm going to multiply it by itself 2 times. And the reason why 2 times is because it's a squared. So 3 times 3 is 9. So 3 squared is a shorthand way of saying 3 times 3, and that equals to 9. If I had 3 to the third power, I would say 3 times 3 times 3. Since the exponent is 3, I need to multiply it by itself 3 times, and that's 27. So that's what an exponent is. It's repeated multiplication. So we always want to make sure what is the base, right? So here in number 17, I see the 2 here, and I see a number in front, 7, and then I see a minus sign or a negative sign in the front. Well, the base is always the thing that's directly in front of the exponent, and if it's in parentheses, it's only whatever is in the parentheses. Here, the negative sign is outside, so I'm going to ignore that part for now. I'm going to ignore that part for now, and I'm just going to focus on 7 squared. So 7 squared is the same thing as 7 times 7, which will give me 49. And then I look at the negative sign, so I'm going to say, okay, it's a negative 49. Okay. Now the second problem here, I see negative 3 to the third power. That's a little bit more confusing. So what I'm going to do is I'm going to ignore everything outside the parentheses. I'm going to put my finger here, just ignore it. And I see that inside the parentheses is a negative 3. So that means I'm multiplying negative 3 by itself 3 times. So negative 3 times negative 3 times negative 3, in other words. So I'm multiplying by negative 3 3 times. So 1, 2, 3, 3 times 3 times 3 is 27, right? I get 27, and is it going to be positive or negative? It's going to be negative because a negative times a negative is a positive, right? This becomes positive, and then positive times a negative becomes negative. So here it's a negative 27. So this whole part here becomes negative 27. But then keep in mind where my finger is, there's a negative in front of it. So what is the negative of negative 27, right? So the negative of a negative 27, so what's the opposite of a negative? It's going to become a positive number, 27. Now we look at number 18. So number 18 has exponents, multiplication, adding, subtracting. There's a lot going on here. So how do we approach this problem? I know it looks a little bit scary at first, but if you just take it one bite at a time, one step at a time, it's not too bad. So here I've written it out. So what I'm going to do first is what we call the order of operations. So what order do we do these operations, right? So order of operations. So when there's a lot of operations, adding, subtracting, multiplication, there's exponents, etc. So the order of operations tells you the order in which you do. You do not go left to right. You got to follow the order of operations. And the shorthand way of people remembering the order of operation is the acronym PEMDAS. So the acronym PEMDAS stands for P stands for parentheses. And parentheses could be anything that groups numbers together, like these parentheses, brackets, squiggly brackets, absolute values, things that group numbers together. Then E stands for exponents. M stands for multiplication. D stands for division. A stands for addition. And S stands for subtraction. The only thing to really be careful of is that multiplication and division are considered one operation. They're the inverse of each other. So if you remember when we're doing division, you could change it to multiplication by multiplying by the reciprocal of the second number. So they're the inverse of each other. So whenever you see multiplication, division, you go left to right. Left to right, whenever you see these two. Same thing with addition and subtraction. They're the inverse of each other. So if you remember, if we do subtraction, we could change it to addition by changing the second number to its opposite. So here we also do this left to right. So these two operations are considered one operation, and these two are considered one. So when we see these, we go left to right. But first we do parentheses, exponents, then multiplication, division, then adding, subtraction. So here in this problem, when I look at this problem, I'm going to say, okay, what do I do first? I see parentheses. That's what I'm going to focus on first. So I zoom in and I just focus on the parentheses, right? I'm going to forget everything else here. So within the parentheses, this is what I have. So within the parentheses, I ignore everything else. So within here, I see a subtraction and exponents. Well, what do I do first? Do I do subtraction or do I do exponents? Well, according to PEMDAS, I'm going to do exponents first. So I'm going to ignore the minus sign. So I'm just going to look at 2 squared. 2 squared is 4. So there I did the exponents first. And then within these parentheses, I have 2 minus 4. Well, 2 minus 4 is going to become negative 2. So this becomes negative 2. So within these parentheses, I have negative 2, and then I have to square it out here, and then minus 5 times negative 3 there, and this minus sign out there. So I start writing the other stuff that I had just covered up. I got laser focused with just looking at this, and this is what I got. Now I'm done with the parentheses because here's negative 2 and here's negative 3. There's nothing more you could do inside the parentheses. Now I do exponents. So where do I see exponents? I see exponents here. So with exponents, you always ask yourself, what is the base? The base is negative 2. It's the thing that's in parentheses right in front of it. So I ignore this negative sign, ignore all of this. I get tunnel vision and I ask myself, what's negative 2 squared? So that means what's negative 2 times negative 2? That will give me a positive 4. And then I have a negative outside as an afterthought. So I have negative 4 now, minus 5 times negative 3. What do I do next? So I have negative 4 minus a 5 times a negative 3. So remember, this is multiplication here, right? Even though I see a minus sign, there's a parentheses next to this number, so it's a multiplication. What do I do first, subtraction or multiplication? I'm going to do multiplication first, based on the order of operations. So I'm going to ignore all this stuff. Tunnel vision was 5 times negative 3. I get negative 15. So here I have minus 4 minus a negative 15. So here, the last thing I do is subtraction. So subtraction, I have negative 4 minus a negative 15. So if you remember the rule of subtraction, you're going to change this to an addition. So I'm going to change this to addition. So negative 4 here plus, and then I take the opposite of the second number. So instead of negative 15, I have a positive 15 now. So the negative 15 here becomes positive 15 because I changed the subtraction to addition. So last but not least, I combine these together. Now I'm adding and I'm walking to the left 4 and I'm walking to the right 15. So therefore, since I'm going in opposite directions, I need to subtract the numbers. I get 11. And is it a positive or negative? Did I walk more to the left or did I walk more to the right? I walked more to the right. So therefore, it's going to be positive 11. Number 19, evaluate the expression when c equals to 4 over 15 and x equals to negative 3/10 for 2x minus c and write your answer in simplest form. So here in this problem, when it says evaluate the expression, that means they want to know what do we get when we plug in 4/15 for c and we plug in negative 3/10 for x. So all we do is we substitute these values in for these letters. So here I'm going to substitute in c for 4/15 for c and negative 3/10 for x. So whenever you have a number and a letter next to each other, that means they're being multiplied with each other. So 2 times x. So here, 2 times negative 3/10. So I'm going to put it next to each other. A lot of students sometimes see this as 2 minus 3/10. That is not the case. Remember, if you have a parentheses next to another object, those two things are going to be multiplied with each other. Minus 4 over 15. So what I'm going to do first is order of operations. Multiplication we do first. So I'm going to do the multiplication first. So when I do multiplication, this 2 is a whole number. I could think of it as 2 over 1 multiplied by negative 3 over 10. That's one way of seeing it, so that you can see this as a fraction multiplied by another fraction. I'm going to simplify this fraction. I see the 10 and the 2 both have a 2 in common. So I'm going to divide the top by 2, I get 1. I'm going to divide the bottom by 2, I get 5. So as a result, when I multiply across, I get 1 times the negative 3 is negative 3. And the bottom, 1 times 5 is just 5. So negative 3/5 minus 4 over 15. So now the main operation is subtraction. So I notice that I have fractions. So the first thing I'm going to do is I'm going to create a lowest common denominator. So 5 and 15, what do they both have in common as a multiple? They have 15 in common. So I'm going to change this to 15. And here, to go from 5 to 15, I needed to multiply it by 3 to get 15. So the rule with math with fractions is whatever you do the bottom, you must do the top. So I also multiply by 3 on top. So negative 3 times 3 on top gives me negative 9. Here, 4/15, I don't need to do anything, so I leave it the same. So here I have negative 9 minus a 4/15. So if you have a minus sign, remember, one of the ways that you could think about this is you change a subtraction to an addition. And if you change it to addition, then you need to change the sign for 4/15. So that becomes negative 4/15. So now I am ready to combine these fractions. So I have the lowest common denominator, which is 15. The top is negative 9 plus a negative 4. So negative 9 plus a negative 4, remember I'm adding now, which is good. And I'm going to the left 9 steps, and I'm going to the left 4 steps. So how many steps am I taking to the left? I'm taking 13 steps to the left. So I add the two numbers together. And since we're in the direction of the left side, that becomes a negative. So negative 13/15. And can I simplify this? No, I cannot. And again, the negative could be on top, on the bottom, or on the side. Next up, we have questions number 20 through 23. And we see that it says to simplify in each one of these directions. And we see letters and numbers, and we're asking ourselves, what's going on here? There's all these letters and numbers, and it says to simplify. So what this section is on is when it says simplify, it means to combine like terms. So what are terms, first of all? Terms are anything that is separated by an adding or subtraction sign. So 2y is a term, 4y is a term, term, right? These are all terms. So they're separated by adding or subtraction signs. So these are terms. And what does it mean for them to be like? Like terms means that they have to have the exact same variable raised to the same exponents. So like terms are ones that have the same variables raised to the same exponent. So I'm going to write this. So like terms are terms with the exact same variables and exponents. So that's what a like terms is. So one way of thinking about this, so again, back to how math is like English, it's like a language. If I told you I have 3 cats plus 2 dogs minus 1 cat plus 4 dogs plus 7 rats, right? So if I told you that this was what was going on, and I asked you to combine or simplify this line of animals, what you would do is you would look at the like animals, the animals that are the same, you're going to combine them. So you have 3 cats minus 1 cat. So 3 cats minus 1 cat, you get 2 cats, right? And then I see dogs. I have 2 dogs plus 4 dogs. 2 dogs plus 4 dogs gives me 6 dogs. And then I have 7 rats, right? So I leave that. So this is what I call simplifying my animal line, right? So you want to simplify by combining the like animals. So combine like animals. And when you combine the like animals, notice that the animals don't change, right? When you 3 cats minus 1 cat is 2 cats. It doesn't become an elephant or a giraffe or something. The animal stays the same, and all you do is you add or subtract what we call the coefficient. So this is the coefficient, which is the number that's in front of the animal, right? So that's the same thing with when we deal with variables and letters. These are coefficients. The numbers in the front are called coefficients, and the letters are called variables. So when I look at these two terms, I ask, can I combine these two terms? In other words, are they like terms? Are they like animals? And the answer is yes. Here's a Y and a Y. They're both the same animal. So when I combine them, all I do is I add or subtract the coefficients. So 2 plus 4 gives me 6, and the animal stays the same, Y, right? You don't change that to Y squared or X or Z. The animal stays the same. Number 21, I asked myself, okay, I'm subtracting. So are these like animals? And the answer is yes. Here's an X and an X. So I'm going to combine the coefficients. -4 minus 10, I'm going to get -14. Because I'm moving to the left 4 and moving to the left 10. So it's a total of -14. And then the animal stays the same, so I get negative 14x. Number 22 is a little bit more challenging, meaning there's parentheses and I got to do some work before I combine the like animals or like terms. So here, this is called distribution. We're going to distribute the 4 through. We're going to multiply it through. So remember, whenever there's parentheses, we multiply with whatever's outside. And so we multiply this through. So when I multiply, I get 4 times w is 4w. 4 times negative 5 is negative 20. And then minus 6w. So now that I'm done with multiplication, now I'm going to see, are there like animals? Are there like terms? Yes, there are. There's 4w and negative 6w. So I'm going to combine those two. So 4 minus 6 will give me negative 2w. And then the negative 20 is its own animal. So negative 20. So I just leave it as that. Last but not least, number 23. I look at this and I say, okay, what animals are the same? Remember, like terms with exact same variables and exponents. So even though I see an x squared and an x here, these are not like terms. Like terms are the ones with exactly the same exponents. So x squared here and x squared here. So these are the like animals. So when I combine 6 and negative 4, 6 minus 4 is negative 2. I keep x squared. Any other like animals? A negative 10x and a negative 11x. I combine these two. Negative 10 minus 11 will give me negative 21. The x stays the same. And then here's a leftover plus 7. And that becomes my final answer. And just kidding, I'm not really done. I noticed that I made a mistake here when I checked my work. So what mistake did I make? It's the first part here. 6 minus 4 is not a negative 2, Nancy. It's a positive 2. So I'm going to take out the negative sign. So the answer is 2x squared minus 20x plus 7. So as you can see, it's easy to make little mistakes, and I didn't catch it until I checked my work. So it's important to check your work